Hello, I'm Veena Khandelwal. In this video, we will learn how to find forbidden latency, permissible latency, initial collision vector, and draw state diagram. We are given reservation table. Here we have check marks in the reservation table. So we find the difference between two check marks in each and every row. So for the first row, for example, it is 6 minus 1, 8 minus 6, and 8 minus 1. Similarly, we find the differences between the check marks for other rows. So we write the differences. Then in here we find that 2 is repeated several times. So we remove the duplicates and write the numbers in an ascending order. So our forbidden latency becomes 2, 4, 5, and 7. So because there are 8 columns, the maximum permissible latency would be 7. So we find the difference between the number of columns and the forbidden latency, and the subset becomes the permissible latency. Now we then write the initial collision vector, and for writing this we begin from right to left. We write 1 for forbidden latency and write 0 for permissible latency. So because we have permissible latency 1, 3 and 6, so at location 1, 3 and 6 we write 0, and for locations 2, 4, 5 and 7 we write 1. Now, because we have zeros in these locations 1, 3 and 6, we can arrive at new states when we perform right shift at these locations. So, we write the initial collision vector at the beginning, and because we have 0 at location 1, 3 and 6, so we perform right shift for position 1, 3 and 6. So, for right shift by 1, we write 1, 0. For right shift by 3, we write 3 zeros. For right shift by 6, we write 6 zeros and fill the remaining columns from the initial collision vector. So these are the columns which are filled by this. Now we perform an OR, so we get the new state. Now in the new state which we have arrived, we once again see that there are no zeros in this, but there are zeros at location 3 and 6, and these two new states arrive. So because these new two states are same, we once again perform a right shift for locations 3 and 6 from these states. So here we write the new state 101101, but we always write initial collision vector at the beginning. Because we have 0 at location 3, so we write 3 zeros. We have 0 at location 6, so we write 6 zeros and fill the remaining columns from the new state arrived. Then we once again perform an OR, because these new states is once again the original state, so no new state has been arrived. So we stop finding new states at this location and we draw a state diagram. So we write the initial collision vector. We perform shifts at location 1, 3 and 6. So we arrived at this new state by performing right shift by 1. We arrived at this location by performing right shift by 3 and 6. Once again in the new state there is 0 at location 3 and 6. When we perform right shift, we once again reach to the same state. When we perform right shift by 6, we once again reach to the same state. Now from this state, if we perform right shift by 8 or more locations, we once again reach to the initial collision vector. From here also, when we perform right shift by 8 or more locations, we once again reach to the initial collision vector. And from this state also, when we perform right shift by more than 8 or 8 locations, we reach to the same location, same state, that is initial collision vector. After drawing the state diagrams, we find out simple cycle. A cycle is simple when only the starting edge it is repeated and no other vertex is repeated. So we see that 3 is a cycle, 6 is a cycle, and 8 is also a cycle, and other cycles is 1 and 8. Then another cycle is 3 and 8. This is 3 and this is 8. Another cycle is 6 and 8. So we can write 6 and 8 also, and we can write one more is 6, 8 and 3. We once again arrive at this position. Now after writing the simple cycles, we find out the average latency 3, 6 and 8. We find the average of these two, we find the average of these two, we find the average of these three numbers. So a cycle is greedy. that cycle whose edges are all made with minimum latency. So out of these three, the minimum latency is 3. So we write 3. Out of these, because we arrive, the destination is 8. So the minimum latency is this for 1. So we write state 1 in 8 as a greedy cycle. Now from these greedy cycles, the latency is 3 and 4.5. So the minimum is 3. So minimum average latency is 3. After determining minimum average latency, we find out throughput. The formula for throughput is eta upon t into 1 upon mal. T time is given 20 nanoseconds. Assume efficiency eta is equal to 1. Minimal average latency we find out 3. So we find out the throughput, which is equal to 16.67 MIPS. Thanks for watching video.